Hello everyone. So today I'm going to explain about data flow diagram. So firstly, let's talk about what data flow diagram actually is. So a data flow diagram is a graphical representation of data flow in any system. It is capable of illustrating incoming data flow, outgoing data flow, and stored data. Now data flow diagram basically describes anything about how data flows through the system. And now you might be thinking about what is the difference between a data flow diagram and a flowchart. So there is a major difference between data flow diagram and flowchart. The flowchart illustrates flow of control in program modules, and data flow diagrams illustrate flow of data in the system at various levels. Data flow diagram does not have any control or branch elements on branch elements. Now coming to so basically by using data flow diagrams, analysts can identify the data inputs and outputs of each process, understand the data transformations and calculations performed within the system, and identify areas of improvement or potential issues in the flow of data. So this is basically the application of data flow diagram. And data flow diagrams are also useful for system analysis and requirements gathering, system design. Basically in software development, data flow diagrams are used the most. Now coming to the next thing, which is types of data flow diagram. So there are two types of data flow diagram: logical data flow diagram and physical data flow diagram. So a logical data flow diagram represents the flow of information within a system at the conceptual level. It focuses on the logical relationships between the processes, data inputs and outputs, and the flow of data between them. And the main purpose of a logical DFD is to depict the system's functionality without considering the implementation details or physical aspects. Now coming to physical DFD. So a physical data flow diagram represents the implementation of the system at a more detailed level, taking into account the physical components and resources involved. It includes information about the hardware, software, databases, networks, and other physical entities that are necessary for the system's operation. So, a physical DFD provides a more concrete view of how data flows through the system and is processed and stored by different components. Now, what are the components of data flow diagram? So, these are basically the components of data flow diagram. There are basically two models: Jordan and Code and Gain and Sarson. So these are basically structured analysis and design methodologies. So Jordan and Code is a structured analysis and design methodology that focuses on understanding and modeling the functional requirements of a system. And it was developed by Edward Jordan and Peter Code, and it gained popularity in 1980s and 1990s. This methodology involves using a set of graphical notations, which we are learning right now, that is data flow diagram. There is also another one, which is entity relationship diagrams, to represent the system processes, data flows, and data entities. Now coming to Gain and Sarson. So it is another structured analysis and design methodology that shares similarities with Jordan and Code, but it was developed by Chris Gain and Trish Sarson, and it is focused on modeling the functional requirements of a system using graphical notations. So Gain and Sarson methodology use data flow diagrams as primary modeling tool to represent the flow of data within the system and between its processes. It also incorporates other techniques such as entity relationship diagrams and state transition diagrams to capture different aspects of system behavior. So this is how we represent entity in Jordan and Code methodology and in Gain and Sarson methodology. So these are basically the representations of external entity, process, data store, and data flow in both of these methodologies, in both of these models, while creating data flow diagram. Okay, so yeah, this was what I explained. These are the basically components of data flow diagram. So firstly, what is a process? So a process represents a function or activity performed within the system. Alright, so the task performed on the data is known as process, and process is represented by circle. Somewhere round edge rectangles are also used to represent process. Now the next is data flow. So the movement of data in the system is known as data flow, and it is represented with the help of an arrow. The tail of the arrow is source and the head of the arrow is destination. Now the next thing is data store, also known as data storage. So data storage includes the database of the system. It is represented by rectangle with both smaller sides missing, or in other words within two parallel lines. And the last one is external entity. So entities include source and destination of the data. Entities are represented by rectangle with their corresponding names. Okay, now coming to some important points about data flow diagrams. So firstly, we have levels of DFD. So DFD can be developed at different levels of detail. As you can see, the highest level DFD is called the zero level DFD or context diagram, which provides overview of the entire system. And the lower level DFDs provide detailed views of processes and data flows within the system. The next thing is data transformations. So DFDs focus on showing the flow of data and transformations that occur within the system. Processes in DFD can represent calculations, validations, data manipulations, or any other operations that modify or transform the data. Now, what are DFD symbols? So in addition to basic symbols mentioned earlier, which we had like processes, data flows, data stores, and external entities, which I just explained, which were the basically components of DFD. So DFDs also use symbols like data flow annotations to describe the data being transferred, control flows to represent the control or sequence of processes, and data flow references to represent the same data flow occurring in multiple places. Now coming to data flow rules. So data flow rules, DFDs follow a set of rules to ensure consistency and clarity. These rules include the conservation rule. All data that enters the process must leave it, as we have studied this rule even in science. So that is the same one. Then coming to the balancing rule, so which is inputs and outputs of a process must be balanced. Then the decomposition rule, which is each process should be decomposed into lower level processes until it is elementary and manageable. Now let's see what are finally the rules for a data flow diagram. So following are the rules for the data flow diagram which are needed to keep in mind while drawing a data flow diagram. So the first one is data cannot flow between two entities. If I summarize all the rules in short, then the first one is data cannot flow between two entities. Second one is data cannot flow between two data stores. Okay, then the third one is data cannot flow directly from one entity to a data store. The fourth one is a process must have at least one input data flow and one output data flow. Okay, then the next one is a data store must have at least one input data flow and one output data flow. Same as the process. Earlier I said a process must have at least one input data flow and one output data flow. Same goes for a data store. Then the next one is two data flows cannot cross each other. Okay, so now next one is all the process in the system must be linked to minimum one data store or any other process. So these were basically the rules for a data flow diagram. Now coming to the DFD for hospital management system. So as you can see, this is the level 0 data flow diagram for hospital management system. So here I have shown the flow of data within the system, highlighting the processes, data sources, the data destinations, and the flow of data between them. So level 0 DFD. At the highest level, the level 0 DFD provides an overview of the major processes and entities in the hospital management system. And it is including basically three main components, which are patient, staff, and administrator. Now coming to level 1 DFD for hospital management system. So it is providing more detailed view of major processes identified in the level 0 DFD. Now let's explore some common level 1 processes. So in level 1 we have some processes like patient registration, appointment scheduling, medical treatment, billing and payment. Yeah, so these were basically few examples of the processes within the hospital management system data flow diagram. And depending on the complexity and specific requirements of the system, there can be additional processes and data flows. Now, the next example which I have for data flow diagram is food ordering system. So this is level 0 data flow diagram for food ordering system. So at the highest level, which is the level 0 DFD, as I said earlier, it provides an overview of the major processes and entities in the food ordering system. So it has three main components: customer, restaurant, and administrator. Now coming to level 1 data flow diagram for food ordering system. So as we know, it provides more detailed views of the major processes identified in the level 0 DFD. So some common level 1 processes are, as mentioned here, we have menu browsing, order placement, order processing, food preparation, order delivery, payment processing. So these were just a few examples of the processes within a food ordering system data flow diagram. And again, depending on the specific requirements and functionalities of the system, there can be additional processes and data flows. So this was all about data flow diagram from my side. I hope you liked this video. Thank you so much.